There we go. So welcome to Quarkus Insights number 128, which is very special because we just released Quarkus 3, and we're in a big room of people here. Yay!
I have to say I'm in the same room, but on the other side.
Yeah, somewhere. And we hope the camera and all that stuff works because we're on full high quality, low bandwidth hotel Wi-Fi. So yeah. So we have a special presentation today because Quarkus 3 was released, and we've done the media and that kind of thing. The announcements on blogs. And this week we have DevOps Greece, where we have a ton of talks about Quarkus 3 and everything else around Quarkus. But we also had a team meeting with a lot of people who are doing Quarkus. And then we actually have a community event where there's a lot of people from around Athens to be here. And we thought, hey, let's just add it up and add someone from the outside too. So we will do, or I'll do a little bit, but Clement will do most of it, about Quarkus and the Quarkus 3. And there'll be a little demo. And then the end is that you put questions, and we try and ask them, both from here and from online. So, Clement.
All right. So say hi to Quarkus 3 because yes, now Quarkus 3 is available and you can start using it. It was the case for the last few days, but yes. So before we go to the Q&A, we want to explain a little bit what Quarkus is, why we did Quarkus. We want to highlight a few things about Quarkus, features that we have introduced in Quarkus 3, improvements and things like that. Unfortunately, we don't have one full day, so we can't cover everything. So, but yeah, it's like my selection of things. So, well, if you follow Quarkus, you have seen this slide many times, but it's always a good remember that before, well, Java is 28 years old, more or less 27, 28 years old, and was designed in a world that was really completely different, where it was mostly targeting vertical scalability, where we were adding more and more resources, and we have this big thing, mainframe and so on, that can run monoliths with plenty of classes, plenty of things. Then the world moved a little bit. It's actually funny because it started moving quite early with switches, architectures, and things like that. But most recently, we have microservices. The goal of microservices is actually to address business agility. How do I deliver my value, my features way more quickly than with a monolith where I need to orchestrate many teams to get anything in? What we are seeing right now, and we are going to demonstrate that too, is that the world is moving one step further to, at least partially, to serverless, where in that case, your microservice is a single feature, a function is a single method if you want to see this thing. And in that case, well, it's actually a lot of function to orchestrate and so on. So what's the difference between all these three categories? Well, in the monolith world, you had one JVM. In the microservice world, you have one JVM per microservice. So it's already more. In the function world, you have one JVM per function. So that's a lot of JVMs, that's a lot of memory, and things need to be adapted to work that way. Because if you start taking Java, the Java ecosystem, and you start putting that in a container, you end up with this. You end up with a lion in a wheelbarrow, which is funny. It works. It's actually happened. See that? But it's not very useful. It's a little bit dangerous. We have no news from the guys that took the pictures, by the way. So, and yeah, it doesn't really fit here. I see that something is wrong here. And that's actually why we did Quarkus. So Quarkus 3 is the next evolution of Quarkus to go in that direction, to provide a real Java, a stack for Java that is truly cloud native, that will work perfectly well with microservices and serverless. It's not only a stack, it's really the complete ecosystem that need to evolve to go inside this new world. And a bit of teasing now, that's what we are going to show at the end. We will have one mobile application that I will use to take pictures and things like that. I will use passwordless because I can't remember any more passwords. So Face ID is great, and at least it works. Then it will upload the picture to an upload service that will run on OpenShift or on Kubernetes. Your application will be packaged inside a container. Then that's great, but as I said, that will be a microservices, but we want also to have a bit of serverless. That picture is going to be sent to a function that run on Amazon Lambda that will take that picture, make it square, make it smaller, and write that into Kafka because Kafka is great. And I will have another microservices that will get from Kafka and display it on screen. So I will take the pictures, it will go to one service, call the function, go to Kafka, back to the world service, back on the screen. The world service is actually an EC2 nano instances that is run in Stockholm. And if you ask, hey, why do you want Stockholm, and why actually are you compiling your Quarkus application into native? If you have these questions, I recommend you to check Holly's. Where is Holly? Holly's in the room over there. So obviously, the remote attendants cannot see her, but she is doing a great talk about energy consumptions, carbon emissions, and things like that. That's why I picked that combination, because at least I reduce my carbon footprint. All right, that was a teaser. First, what did we do? So Quarkus is based on 4 principles: frictionless, build-time principle, reactive core, prod, and cloud readiness. So let's start with the frictionless. Frictionless means that when you're developing, we don't want you to be stopped by every small things you need to do. Oh yeah, I need to start my database. Oh, by the way, what's the admin password, the default password of Postgre? I can't remember that. Every time you need to Google it and things like that, that's bad. What we want with Quarkus is to remove all that frictions so you stay in the flow. How is that implemented? Well, we have very non-feature like the dev mode, dev services that are still there. We improved a little bit. We have continuous testing to, I'm not sure we work too much about that in Quarkus 3, but it's still there. It works very great. Quarkus 3 comes with a completely new dev UI. Max will demonstrate it. In terms of deployments, remember, containers, functions, EC2, 3 different type of workload, one stack. Quarkus is understands that to say, oh, you want to build for a container, or you want to build for a function, or you want to build for VM, because EC2 is kind of VM. It will understand that, apply the right optimization, provide the right artifact. So for example, for a function, it's a function.zip and things like that. Finally, we think about the developer. So Quarkus is developed by really hardcore developers. So we know that it's very, very boring to have boilerplate code everywhere. And we want to remove that. That's what we do with Panache. And we have many Panaches. Panache, I don't know. Well, it's a French word, so I would say Panache with an S and not pronounce it. We have obviously Hibernate ORM with Panache. We have Mongo with Panache. We have Panache logging. We have plenty of Panache like that remove all this boilerplate. We have our own reactive programming library, which is Mutiny. While in the Java ecosystem, most developers are used to the Spring annotation. So you can use the Spring annotation thanks to the Spring compatibility layer. And we have, obviously, build time guided optimization and build time analysis. And that's the second principle. So when you start a traditional framework, you do Maven package, Gradle build, you get a WAR, a Fajar, whatever. And then at runtime, it will start locating files on the file systems. Because Java is 28 or 27 years old, well, there is a good chance that it will read XML things, Hibernate XML, CDI XML, Bean XMLs, and things like that. Then once this is done, it will scan the whole class path to find the annotations, load the classes, and so on. Say, how you are this, you are entities there, you have beans there, and so on. And then for each framework, the framework will get that results and start to understand what it needs to happen. And finally, start the server, start the management, start the pool, start the connection, and so on. So what does Quarkus do differently? Well, actually not so much. We do exactly the same thing, but we do it before. We do it at build time. So at build time, we are locating those files, load the configuration, at least what can be done at build time. We do the class path scanning at build time. So all the frameworks knows what they need to do at build time, which means that at build time, they know exactly how they need to be initialized. So in our final artifacts, they each framework can actually write exactly the set of instructions that are needed to start. What are the beans? Where they're injecting? What are the entities? All this stuff. So it's there, which means that at runtime, we are much, much faster to start. Not because we are smart or we have super optimization. We do, but yeah, just because we do a lot less. That's simple. There is another benefit is the memory, because all the memory that is used at build time doesn't have to be used at runtime. So I know you want numbers, so let's get you some numbers. If I stay in the JVM world, pure JVM, my startup time, thanks to this, with an size of 64 megabytes, are for the services that we are going to demonstrate around 1 second. 1 second for the upload service, running on Kubernetes, accessing a database. The wall service is 0.6 seconds, and the query function is 0.8 seconds. I will go back to that when I will do the demo, how we achieve this. The memory consumptions are around 150, 200 megabytes, which if you compare with the real Java applications, traditional Java application is half of it, a third of it. So it's already a big improvement. A side effect of this build time principle is that we can actually compile your application into a native artifact. Compiling into native means using a compiler. We are using Mandrel, which is our variant of GraalVM. It's hosted on the GraalVM ecosystem. There is a large collaboration with the GraalVM team. And what we want to do here is that we collect enough metadata about your application at build time so we can invoke that compiler to produce an optimal native executable. Well, thanks to that compiler, with a bit of work, you can get almost any Java application running more or less in native. The tricky thing is that if you use the same amount of memory than a JVM applications, there is absolutely no interest in going into native. It's only interesting if it really brings benefits. That's why we want to really build optimal native executable. If you go into native, then our startup time are, well, sub-seconds, where we had around 0.1 for the upload service, 0.2 for the wall service and square function. In the Java world, that's called immediate, so that's instant startup. Yeah, we can't go under that. The resource consumption is also smaller. Why? Because during the compilation, the compiler has removed every part of the JVM and everything that are not required, so we know exactly what is needed. Third principle, the reactive core. At the core of Quarkus, at the center of Quarkus, there is a library that handles all your I/O. That library is Vertex, it's based on Netty, and that's what we call our reactive core. It's going to use the resources of the operating systems very, very efficiently. So, without going too much into details, the reactive model means that you will have I/O thread, generally called event loop, on which your code can be invoked and you should not block, and can be a little bit complicated in terms of development because you should not block, so you need to use a development model that doesn't block. However, for most people using Quarkus, well, they didn't change how they developed. They're still using worker thread, and that works perfectly well because at the extension level, for example, in REST Reactive, we detect what kind of signature, what kind of code we are running, and we decide among 3 different execution models. You do regular code, worker thread, safe, works, perfect. You have already optimization because all the I/O part until the extension part runs correctly on the I/O thread and so on. So there is already a lot of benefits on doing this. If you're using Java 19 or Java 20 or the next Java, so 21, and you want to use Loom and virtual threads, just add run on virtual thread, and you can run your Quarkus application on a virtual thread. Finally, if you really want high concurrency and you know what you're doing and you want to use reactive programming or Kotlin coroutine, it will run directly on an I/O thread, meaning that you have no switch of threads for the processing, super fast, very high concurrency, comes with a complexity in terms of code. Last but not least, Quarkus, and since the beginning, has focused on production and cloud readiness. So the first thing is that Quarkus is 4 years old, more or less. I think the anniversary was not so long ago, like February or March. And basically what happened when we created the first version of Quarkus is that we reused a lot of things of the ecosystem. REST-easy, Hibernate, Vertex, and so on. All these were already production ready. We knew how to tune them, how to use them in production. We had lots of feedbacks and lots of experience with that. This has continued over time. So 4 years later, we have a stack which is really production and cloud ready. So what does that mean? That means that we provide everything you need to make your application robust. So it's designed for resilience. Provides a stability pattern such as circuit breaker, retry. It's non-blocking by default, so we avoid blocking threads and things like that. In Quarkus 3, we have looked into the implementation of what I call graceful remediation. So graceful remediation is when something bad happens, and it will, instead of crashing or instead of saying, no, I stop here, we will try to recover nicely and successfully. Then it's designed for security. So in Quarkus 3, we have TLS 1.3, we have a config encryption that is coming, we have better OIDC support with all major OIDC providers there. So what they are. So if you want to authenticate against GitHub, against Google, against Facebook, against, name it, it's there. Against Spotify, we provide the right configuration for all these cases. You just put that, you're done. Well, if you're like me and you can't remember a password, you can use passwordless with something called WebAuthn, and then just delegate the authentication to Face ID or fingerprint and be done with that. Design for production, I already mentioned it. Quarkus is going to apply the optimization for containers and JVM and Kubernetes and function and so on for you. Obviously, you can do your own, but by default, we come with the right good practices. You may ask, what are those good practices and how do you know that? So the trends we have here when we do Quarkus, so a large part of the team works at Red Hat, and Red Hat has a lot of experience going from the Linux kernel to the operating systems, to the virtualization layers, to the containers runtime, to the Kubernetes runtime, and so on. So we have access to people that will tell us, hey, that's how you need to do things. And I'm forgetting about OpenJDK, and we cover the whole spectrum. So we know what we are doing. And finally, and that's more and more important today with observability and SRE and DevOps. So we design for observability. We have health and metrics. We improve tracing a lot. We are embracing OpenTelemetry in Quarkus 3. We are waiting for OpenTelemetry logging, which is coming soonish. Bruno can confirm that. And in Quarkus 3, we have also the implementation of a management interface, which is when you run your application, you can have a second port for health metric and so on, so it's not exposed on the main port. It's slightly different. It differentiates both things like management and main app, more or less, which means that, it's slightly different. So, for example, Kubernetes can have only access to the management interface and things like this. All right, demo time. Max, you will have to come here.
Yes.
And so again, remember, we are going to have our phone applications that will log in with HTTP and WebAuthn, and we'll go to the upload service that Max is going to show you. Then it will call a squarer function. I will discuss a little bit, then go to Kafka, the whole service, and back on the screen. But first, what do you want to show us? So
just the terminal.
Yeah, there it goes.
Okay, thank you. Oh, the camera.
Yeah, maybe we need to improve the size. Nope, no, that's not what I wanted to do.
What could go wrong? Okay.
Yeah.
Great. So, all the stuff you talk about is the foundation and principles we have about Quarkus. What I hope to show here is the start of stuff we've done in Quarkus 3. And one of the big things in Quarkus is the developer experience. And so I'm in an app, or not app, or directory that looks like this. Big, normal Java project. There we go. And I'm just going to write, use Quarkus Dev. Quarkus is the CLI they have installed. You can also use Maven Quarkus Dev or Gradle Quarkus Dev, but I like the CLI. It starts up, and this is not a small service, so it takes, and you're running streaming, that kind of thing, so it takes a while. So you see here in the background, down there, it's actually starting up some Postgres and some, that's a bunch of stuff. And it actually didn't take that long, and the app is up and running, right? I think the startup is like 4.8 seconds, which is actually slow a bit. But the idea is everything is started up, and it does all the stuff that Clement is showing in a few seconds. So the cool thing I want to show that is new is our dev mode. So if you've used before our dev mode, it looks very bright here. Zoom in a little bit. But this is the place where we can see all the extensions we have. And this, as I said, this is not a small application. It uses a ton of different extensions. And in here, you can browse and see the different...
it's a macro service.
It's a macro service? Okay. But you can see like what beans are running. You can see... I need to zoom out a bit. You can browse... Where is it? The REST-DC reactive...
Yeah, next. Yeah.
There we go. We have like how well reactive is your application. Not a requirement for it, but you apparently are a bit good. And there we go. Come on. But anyway, so the thing is, we have this new UI, which is very dynamic. It does logging the whole thing.
But,
and the very important feature,
yes,
is very critical, is that it has dark mode, right?
Hey, applause, dark mode. Come on.
And by the way, Philip, who's not here, I know he spent a lot of time to get the dark mode in. That was very important, and the whole dev UI. But that was the primary reason. We can get dark mode was to do a new dev UI was we can get dark mode. Secondary was that this is very extensible. Every extension can add stuff in a much nicer and more dynamic way than we could before. There's stuff like you can see the configuration. Again, the features in this is very it's the same as the old one, but it's just much more fluent. And because we are utilizing web components and modern technologies, we can do much more. And you have
WebSockets, something like that. So it's new generation. It's much more modern.
Yeah, and so and the way we see Quarkus 3 is we've moved up, and we'll get into a bit more about the foundation we've changed. But don't see Quarkus 3 as the end goal. Quarkus 3 is the new start, and a lot of stuff will come there, especially in for example, dev UI. So here I'm browsing, properties. I can see diff ones. The log on the left is what we call build times, things that can only be done at build time, so we can optimize. And you can change values and so forth. And there's a new service called information. There we go. Oh, so let me do the dev service first. So here you can see the dev service that's running. PostgreSQL. So it should be a bit more, but anyway. And you can see the details. You can see the connection URL. And if you, for example, you can also run like a kube, what's called kube service. You can see the connection information, Kafka, and that kind of thing. And for example, the information, this is a new extension. So if you go Quarkus add info, you get information about the system. And you go like, why would I use that for dev UI? But the thing is, at runtime, there is this endpoint, and I'll zoom in a little bit, that gives you, information, which can be used for your different monitoring and that kind of tool to see what's running.
Let's be honest, there is a bug here, because here is written Java 20, which I use because I'm using virtual thread in that application. And if you go back to the other UI, information, there is this version which is hard-coded.
It's already been fixed.
See, Georgios, you're really reactive.
Yeah.
Great.
So 3.02 will have.
All right, good. Yeah, we do continuous delivery. We do it very often. Fix issues. Okay, so anyway, that's the dev UI again. If for some reason you are using an extension that somehow was not migrated, I think 97% has been migrated. You can still go back to the previous UI and be sad and
no dark mode.
And no dark mode. So we go back to this one. Right. There's other stuff like this. There's the log down here. The testing, unfortunately, don't have a test, but if because for some reason,
why do you need tests?
I don't know.
I'm confident.
Okay, good. So anyway, if you had tests, you could run what continuous testing in here, and it will start up a separate dev mode where you can have a separate database, and you can be editing and live changing, and you see the result up here. So that was dev UI. the other one, I have to move this over there. So that's the application running on the left. We have a feature that's, well, again, the CLI. You run it, you see it has a ton of commands. Some of them are deploy, which I think you were going to touch upon. There's building images, which are also new features, and like create apps, add and remove extensions. But the new section is down here is the, I can't select things. Whoops. The plugins. So you can now do plugins. So if I, for example, do, sometimes I get upset and my Quarkus is not doing what I want to, and I want to kill it. So now I'm running command Quarkus kill,
which is not installed.
It's not installed. And it's going out and look, hey, in the Quarkus registry, hey, there's a kill command that you want to install. And you say, yeah, I want to do that. I want to install random stuff from the internet. It normally, and I just realized,
call a function, and sometimes, yeah, a function may take some time to start. We will see how we have improved that. So you need to use a stability pattern. So retry, timeout, circuit breaker. We also want to have metrics like time and counted. Again, it's all built in. You just add the right extension, use the annotation, and boom, you're done. It works. The REST client, again, that's an old feature, but it's always interesting to see how it works. Here, we are isolating the HTTP interaction and modeling them using an interface which avoid having HTTP bleeding everywhere inside your code. And that's super important because HTTP, while everybody believes it knows it, it's actually super complicated. So it's better to just avoid having HTTP code everywhere and just do that. It will generate the right client and be done with it. So in terms of configuration, something I wanted to show here is that that client is actually going to use service discovery to locate my function. Because obviously I could use a direct URL or something like that, but yeah, if I have several environments and things like that, it's better to just delegate that to our service discovery and load balancing library, which is named Stork. So I just say as to Stork, okay, locate me the function name in Stackworm. I give some hints. I want to use this a new service discovery provider, which is just looking for the API gateway, calling my function. Again, it's in Stockholm. Well, it's in Amazon in Stockholm for the same reason I mentioned before. And my stage is production and things like this. Let's go to the function now. So second thing, my function is using Funky. Funky is an abstraction on top of serverless framework. It works for Lambda, Azure function, as well as Knative serverless. So you just add @func, which is kind of cool, and be done. So you get this, you return that, you do image manipulation, funky things, and that's it. Then I want to write to Kafka, and to write to Kafka, it's as simple as this. Add channel, where I want to write, it is going to be my Kafka topic, and use an emitter, and yeah, you send my response directly. No need for serializer and things like that. It's all generated for you if you don't provide one. It will use JSON. In that case, it's the pictures. It will do the write base 64 encoding and things like that and things like that. That function is actually using a new feature from Amazon Lambda, which is named Snapstart. So it's enabled using this Quarkus Snapstart enabled true. And basically, it's a snapshot and restore technology. So when I will deploy my function, it will start running partially my function, then take a snapshot of the memory. And when I invoke that function, it will just restore from that point. So you save a lot of cold start because it's already partially started. Super great features with Snapstart. It's not this, it's something we do. It's the pricing model. You only pay for the invocation, not the snapshotting, not the restoration, just the actual invocation. So it is, yeah, it's interesting because yeah, it's you actually pay slightly the same, well, maybe even less money than if you deploy into a native executable. Speaking about native executable, it's the last application we have, which is a world service. It's compiled into native, deploy into a Lambda using an Ansible playbook. The Ansible playbook will be made available. All this that code is already on GitHub repository. So here it's a plain, I don't know why I have this. It's not required anymore. A plain, simple application which just return my stream of pictures as an SCC, server sent event, using REST is reactive, just works out of the box. So this has already been deployed because I didn't want to play too much with the bandwidth of our hotel. So let's see how far we are.
So Cameron, just so you know, we actually have about 20 questions queued right now.
Okay.
So we might take a little bit more than
all right. So what do you want to do? I finish the demo and then we take the questions?
Yeah, I think so. Yeah.
So my application got deployed like this. So how did I deploy it? So I just did this. I'm not sure you see it. So let me do it. Quarkus deploy. Great thing with this new CLI, you don't even have to have the OpenShift extension, the Kubernetes extension. The Quarkus deploy, we understand that and do that for you. And you just say, hey, I want to deploy to OpenShift using an image build. Boom, it's done. Not going to do it because I want to save bandwidth. And we have 20 questions already, so maybe we need to go a little bit faster. So it's deployed, it's there. It's there? No? Yeah? Yeah? No? Yes, here. That's my application. That's what we have right now. So as you can see, I'm very bad at taking selfie and pictures because they're all reverse. But anyway, let's try this. Let's try this live. I'm going to go there, taking a pictures. Choose file. Yep.
So you're just gonna look nice?
Yeah, look nice. Yeah,
Okay.
you're really nice, Max. Okay. Yes.
Perfect.
We have 50% chance that we looked like this, but let's see. I'm going to click the upload button. Uploading the pictures, this will go to Kubernetes, then invoke the function, then go to Kafka, then the whole service will get it, and normally in a couple of seconds, we should see appearing it here.
Couple
of seconds. It's still uploading, so please do not use Twitter, Facebook, or whatever when you are in this room. I need the bandwidth right now.
Yep.
Ah, yes, see. Hey.
It's not Quarkus, it's the bandwidth.
Yeah,
Yeah.
it's actually the word because the rest is pretty fast. But as you can see, I took a picture on my phone using Face ID for the authentication. It goes to a container running on Kubernetes. Then it calls a function that is also implemented using Quarkus, using Snapstart and Funky. Then it goes to Kafka, thanks to our Kafka support. Then it goes to an EC2 instances running in Stockholm, compiling to native, SSE to back there. So yeah,
and that worked despite that we're in a very low quality
Yeah.
Wi-Fi location.
Yes,
Yeah.
and I'm still very bad at taking pictures, as you can see.
Well, it's up. It's the right side up.
Yeah, well, for once, because you see, I tried twice before.
Getting good.
All right, so let's continue with the slide before, or yeah, maybe we do that and then the question.
Yes.
Okay, right. So why Quarkus 3? So Quarkus 2 was really, I can't even remember. It's just, yeah, well, it was 2 years? Yeah, something like this, right? And the state of practice and the technology has evolved. And one of the big evolution we had is Jakarta EE10. And Quarkus 3 is fully Jakarta EE10. So it uses the Jakarta namespace for all your classes. At the same time, you say, hey, as you are doing modernization, let's use Flow instead of reactive streams. We have the adapters for reactive streams and Mutiny 2 on Vertex 4.4 with IO ring support, because that's also a new evolution. It's a game changer in terms of how we handle IO at the operating system level. So Vertex 4.4 is integrated. It supports IO ring. Diatexis, you may never have heard of that. It's actually an effort to rewrite our documentation in a better, more structured way. That is going to take a few time because we are not really good at writing documentation. We have a team helping us for that. But sorry? It's a Greek word, actually. Yeah, so yes, it's actually a tribute to the place we are. We are in Athens. Not sure if we'd said it. The update tools, you have a Quarkus 2 application, you want to go to Quarkus 3, Quarkus CLI to do the update, boom, and there you go. And last but not least, Hibernate ORM 6, complete rewrite of the SQL generation and a lot of cool things inside. Yes, it's there, ready to be used, tuned by the team, Hibernate team itself. So very happy. Couple of new stuff, new gRPC, CLI plugins, Max, you say that. Management interface, we mentioned it. Virtual thread, mention it better, and we have more stuff coming. IO ring, new dev UI, and dark mode. Multi-arcs images, that's coming. It's right now it's already usable, but yeah, it's not really made for bare human. ARM support, Pulsar connector will be delivered in June because Ozan is working on it right now. I hope that you are developing it right now. So it's really coming, and we're really close to release it. So last slide, why Quarkus? You develop without friction. You deploy without fear, with all the good practices. You operate without stress. We have all the metrics, the health, the tracing you need, and you run without bankruptcy. Because what I didn't say is that thanks to our deployment density and so on EC2, you reduce the type, or EC2 or Azure and so on, you reduce the type of instances. On Kubernetes, you can deploy a lot more on the same set of resources. That's all I have, and it seems that we have a few questions, Max. So
yeah, and I think one thing also is updating in peace. So if you go back just one slide, so we don't we didn't easily upgrade Quarkus. We didn't change the 2 or 3 in an easy way. Oh, sorry, that makes no sense. The reason why we prefer to be staying on Quarkus 2 and just continue to improving over time. But the Kata EE and Mutiny and Flow and Hybrid OS 6 changed package. Some of these changed package names, especially Jakarta. So it just became we had to kind of take a hit and make it a bit make an effort and make it so people can upgrade, but we know that it's not going to be easy for everyone. So that's why we had the Quarkus update tool. It's using open rewrites. Work done together with the migration toolkit team that is a Red Hat product. But we used the open rewrite project to do the migration steps, and it handles all the Kata stuff, all the Mutiny, all the Flow, some of the Hibernate things. But we just want to be honest. The Hibernate ones there's some stuff that's changed. So that's probably we have a very dedicated guide to do it. but we've done everything we can to make that experience smooth. And the great thing is we have that feature now to make it every continuous update will be a small step. So yeah, I think that's an important thing to be honest about, that this is a big breaking change, but we've done everything we can to make it smooth. And so far we hear people being fairly happy about it. So yeah, so we got a ton of questions here actually.
Should we? Yeah, maybe we will delegate some of the other to the
we'll
Quarkus
see.
team,
Some of
which
them
is
are,
here, and so
we'll see.
can...
So first one we had, where we go? Well, first one was that someone was saying that Quarkus is too infectious. Since I showed my prototype in a small meeting, 2 teams adopted it. Thank you for all the outstanding work. So thank you for, that was a great first question. And then comes the hard one. So I'll do them in time order. So Timo says, any updates regarding Kotlin support in 3.0? So for those who don't know, we like Java is our main language and bread and butter. From early days, we have Kotlin, and we are considering a first-class citizen of it. We've done a lot of work, even just in Quarkus 2. So if you've used Kotlin with Quarkus in, like say, the Quarkus 1 time frame, you might have had a bumpy experience.
Even the early tools was not
great. So later tools, it got better.
Yes.
So I would say in somewhere in the 2 line, we got to a good state, especially around dev mode and some of the
and coroutines.
And coroutines, yes. Nope. But so I don't think. Well, I know in Quarkus 3 we've changed some of the. Let's see, George is shaking his head, but we did change some stuff in around Kotlin to enable some of the pact testing. And pact is based on Kotlin, but in general, it should be the same experience, as far as I know, on there. So if you, for some reason, see that it doesn't work better or the same, let us know. So in general, should be all good.
The Gradle support has been improved. And when you do Kotlin, you generally use Gradle because it's
so language. The Gradle support has also a lot of that stuff happened in the late 2x's, but definitely in 3 we've done more, and it's quite good in that sense. So there's problem with Twitch streams. It's good. And then here's about because this came when you saying everything is fast and quick. And Mila says, why I don't get fast startup times as you state. My service is starting around 14 seconds. I use the JVM instead of GraalVM. So why moving to Quarkus didn't solve all problems, basically, right? So, of course, you could have bumped into a bug, but most likely what we see is that either you might have a massive application that is doing stuff that is outside Quarkus kind of touch. You could have 10,000 entities, and that still will be slow for some cases. But I see the comments was this, similar to what I'm going to say, is that there's a lot of you're most likely doing maybe some I/O or some coordination that is still causing startup issues.
We see that often with data migrations because there is lots of back and forth with the database at startup. Which actually is something, and I didn't mention it, is now if you deploy to Kubernetes, can be isolated in its own init container. Ioannis did that. That's forgot to mention it, so I mentioned it there. So it's super cool because it's really how it needs to happen in Kubernetes. So if you use such kind of data migration tools, that might be the problem. If it's not that, well, open a discussion on Quarkus. We will be happy to discuss that.
It could be anything. So, but in general, 14 seconds is for us very, very, very slow. But we have seen it if you've taken an existing application, moved over, and used third-party dependencies that isn't, let's say, quantified in that sense. So yeah, if you have the issue, let us know, and we'll happy to help. And then you mentioned a bit, but I think it'll be worth covering. He's saying, is IO available in Quarkus 3.0? Is there a dependency a specific JVM Linux I should use?
So it's not a JVM problem. It's really a Linux kernel problem. So you need to have a quite.
Maybe you want to touch on what IO actually is.
Maybe. So, wizard slides and like that. Yeah, that's going to be. Generally, if you're on Linux, so IO is a purely Linux technology. On Linux, the IO model that was used so far is what we call ePOL. So basically, for each I/O you will do. It will write a file descriptor, and then you have a loop that will go through all the descriptors which are declared ready, and then do the I/O and things like that. I/O ring change that approach with two buffers that avoid a lot of back and forth between the kernel space and the user space. So how it was presented is that you can see a 30% improvement in terms of throughput switching to I/O ring without changing anything inside your app. It's obviously depend of the applications. It depends on a lot of things. I've seen 10, 15. I think Sunny. Where is Sunny? Sunny, how much did you see when you did that for Infinispan? In terms of improvement with I/O ring. Oh, for Hibernate Reactive, yeah. Right. So 50?
Well, 100%.
100%. Wow. Yeah. Okay, so even better than what Intel announced. So yeah. So it's there, but you need a fairly recent version of the kernel. I think it's 6. I don't have the number. Franz, help me. 6.5? 5.1. 5.1 is a bit old, no? Yeah.
There are a set of features that give the best possible performance, given that in the Linux kernel is not under development, but let's say that new features are being added.
So you need the most recent one because new features getting integrated and optimization are getting integrated right now. But yes, so with Quarkus 3, it's still a little bit well, it's not. Well, let's say clearly, it's not documented because I didn't write that documentation. But once it will be, it's already usable. I did some tests, and we want to improve a few things with Franz and Julien Viette, which is also here from the Vertex team. But yeah, we are really happy to have that, and we recommend you to try it if you are interested to have better throughput.
Yeah. So all the mechanics are there in 3.0, but we'll document it in the upcoming release.
Yes.
And yes, it will require a certain version of Linux.
Yes. So
we'll document
5.1, but yeah, I will recommend the very. So if you are using the latest Fedora, working at Red Hat, it will work.
Exactly. And I just noticed, so the Milad who said about the slow startup, he says, I've only used the Quarkus lib. So I'm just guessing here that if you actually just tried to add Quarkus as a dependency and maybe use Qt or some other library, which you can do because Quarkus is just Java. Maybe just a guess. Maybe if you're not using the Quarkus plugin to actually do all the build optimizations, you won't see any benefits. I've seen that actually before. So yeah, just adding Quarkus as a dependency doesn't fix it. You have to use the Maven Gradle build plugin for
Quarkus Core, Quarkus Bootstrap, which are hidden generally when you create your Quarkus app.
Yes, right. So that could be one for Milan. Then there's a very specific one. I'm not sure what that one is, but we'll just do it. So he's saying, for audience says, is it possible to specify build step order of execution to ensure my build item is produced before Qt produces its build item? That's a long one. Well, I think the thing in general is if your build steps they should be ordered correctly.
Well, but here you may want to introduce what we call a virtual build step, or now we have new annotations to do that, to say that you want to be run before or after that one. So there are techniques, not necessarily the most beautiful things, but yeah, we have things that can do this.
That's like very specific. So just let's say like ask us on Zulip.
Yes.
Yeah. Ask us on Zulip.
Well, on Zulip next week, or GitHub issue, and so it's persisted somewhere.
Yeah. Here's one more, a bit more general. Does Hybrid Reactive support Kotlin coroutines suspend function in Quarkus 3.0?
Sorry, I didn't get it. I can't read your screen from.
No. Does Hybrid Reactive
support
Kotlin coroutines suspend function in Quarkus 3.0? So Hibernate Reactive doesn't work. In Kotlin coroutines, you would use classic Hibernate.
Yes, I don't believe we have support for Hibernate Reactive yet. I'm looking at Georgios and Sunny.
I don't think we have.
Sounds like a great question to post. Because
yes.
The general idea is that anything we can do, anything that works on the event loop with reactive I/O, we can do.
Yes, we can.
Kotlin coroutines just needs a little work.
Yeah.
From our far side.
Yeah.
So
In case I'm not sure the audio picked up, but what Jordan was saying is anything that works in quadric coroutines, we should be able to do in Reactive. But yeah, ask the question in the forum. We'll be able to give a better.
yeah,
answer.
but probably just missing features that can be easily implemented.
Yeah. Let's see, what do we have else here? This was from Kevin. Sorry, Kevin. When you were talking about running on virtual threads, maybe I mentioned shortly. He says like that defeats the whole goal of virtual thread users on Loom, and I think a developer don't really care on which thread is run. Doesn't it add complexity to an application? So he's like, why should we care about running on app limitation?
Actually, in an ideal world, which probably will happen in the next 5 years, that's what you will get. You won't care anymore, and we will run on virtual thread automatically. Unfortunately, the reality is not that simple. There are a couple of limitations to Loom as it is today, which make it dangerous to switch completely to virtual thread. 3 problems. The first one is pinning. There is some construct in Java, mostly synchronized, native, and things like that, that will pin the carrier thread. So without going too much into details, it basically means that you are going to block all the virtual threads that need to run on that carrier thread. So kind of annoying. Second one is monopolization. There is absolutely nothing that will tell you, hey, you use that carrier thread, you have been mounted for too much time. So if you do a lot of CPU intensive things, that can be problematic because the rest cannot run. And the last one is the usage of thread locals, especially in the case of pooling. Well, when you use pooling like this, when you had a couple of threads, that was fine. But now if you can have thousands, and it's basically going to be thousands pool of one, doesn't make any sense in terms of allocation. It's pretty expensive, so performances are not good. All 3 problems are things that we are trying to address one way or another. We have a performance team which is taking that very seriously and going to benchmark. We have improved already Netty. France, which is here, fixed a problem in Netty with Loom. Jackson also has a problem with thread locals. The Jackson leader has committed to fix it in the version. I can't remember which version, but the next one or the next one. And so there are problems in the Java ecosystem in general. There are also problems with the current APIs that the JDK offer, which doesn't let frameworks, not only Quarkus, but Spring and so on, to actually hook into the virtual thread mechanism. So there is things we would like to do that we can't. But yes, it's give it a couple of years. That's there. And what you want, it will be there. But yes.
Yeah, basically Loom has a lot of potential, but it's not something that can be globally enabled because of the ecosystem is just not there yet.
Yep.
So we added an annotation to let you actually play with it in a safe manner. As long as you're aware of limitations, you can do it. But we don't want to enable it by default yet.
Yes, because it can be really, really bad. So
yeah.
Yes.
Okay, and then we had since we talk about like making things stable, Milad says, is version 3 reliable enough to switch to it? Yes, it is.
Shortest answer ever.
So we've done again. There's some stuff has changed, like Hibernate ORM6, but again, it's been tested very well. Yes, it's a new version, but it's definitely ready to try out and produce. We've had CRs and have feedback, fixed a lot of issues, but it's not like all the fundamentals has changed. It's just we've changed the namespace of Jakarta, and otherwise it's more Quarkus 2.20 than it's a 3x in that sense.
Yeah, and remember that each extension also have a status. So some extensions are still I can't remember the experimental.
Experimental
so you can check that. While some extensions have been experimental for a long time because we forgot to update the status. That's also happened. So if you say, hey, but what about this? Ask a question, because sometimes we just say, oh, yeah, right, I forgot to update that status.
Yeah, no, so we haven't tried definitely. We believe it's the one to try out. Then there's dark mode. Someone said, dark mode, next step is fully customizable theme. And, and then
too
I
bad
saw-
that Philippe is not here.
Well, he's actually here. He's following. He does say, well, there's actually a PR, so that might be coming.
Oh yeah. Cool.
That of course, that's the important part. And then we have every time we show Dev UI, there's the same question: is how do I get this in production? Do you want to take it or?
Yeah. So the Dev UI initially was intended to be a Dev Things. That's the name. Dev UI, Dev Things. We got more and more requests to get part of this in production. However, we wanted to have the management interface first because at least you are not going to expose that on the main port and main interface. We also wanted to have security first for the management interface, which Sergey has implemented. So we have YDC and login password. So sorry. Anything is possible. I connect to Sergey. So see that Face ID. I want to connect with Face ID to my production system. So yeah, we want to go there. We're just going to do this step by step. It might not have all the features of the new Dev UI because there are things that are really dev centric. Typically you are not going to build a container on a production. So that's
the thing is the Dev UI is doing more than just Dev UI. It's showing interesting features and information that you also want to do in production. But some of these features we just don't want to have in production. Like exposing the whole configuration, and you can edit the thing. Fun to do in a demo. Production, not so great. And also the thing, remember, in Quarkus we have this separation between build and build time and runtime, but we also have a separation into basically dev time. The dev time is not trying to fit into the smallest memory and use the less resource. It's literally using all the dynamic features we have in Java and all this stuff we can do to make the developer experience like super fast and super pleasant. We just can't have that in production. So, but the thing is, what the technology that we're using in Dev UI is gonna be or is reusable for extensions to kind of maybe we could now with the management UI expose some management UI pieces. But this is not, we don't have anything, but we have all the pieces that could happen in the 3
we need to build step by step.
Yeah.
However, it will be very interesting if we know the features you would like to use like this, because there is obviously the information endpoint, there is health maybe and things like that. Well, health, if you read, might not be helpful, but so if you can list the feature you would like to see like this, that would let us prioritize and do the right thing.
As one example, for example, is the Open API, what's it called?
Swagger.
Swagger is something we have in dev mode, but we can also optionally expose as a production thing, and that's the kind of thing we probably do in the future. Okay, we have this goes back to your Amazon Lambda demo. He says the snapshot cannot be mixed with native compilation.
No. Right now, it's really two different technologies. So the process is relatively simple. You write your functions. You use Funky or which I would recommend, or any other Lambda support we provide. And then you need to decide if you want to stay in the JVM world and can use Snapstart to reduce drastically the call startup. You stay in the JVM world. It will use quite some memory. So you need to take into that interaction, or you compile into native, and then Quarkus is going to deliver its own provided runtimes. That's Amazon lingo here. Both works, both have pros and cons, so you will need to pick. You may actually try both. In Lambda, you can even have a A/B testing. So you deploy both, and you say 50% of the traffic on the native and 50% on the Snapstart. You decide, but they are exclusive mechanism.
And as in theory you could, but something that is hidden in, because there's a lot of stuff going on. So the way Amazon actually does this, they have a virtual machine that goes and do the snapshot, and then when the request comes in, they can just resume. But that resume actually takes about the same time as starting a native image.
But it depends on the application.
Yes, right. But so it might not even be a benefit for native image. But the problem is in Amazon. In Amazon, if you run native image, you have to run a custom container. So there's like an overhead.
Yeah, so the pricing
So-
model is different
yeah.
because with your own runtime, you pay for the full life cycle. Then when Snap start, you only pay for actually your application execution, your function execution, so not the restore and so on. So
Yeah.
native will use less memory, so you pay less per microsecond. Snapstart use more memory, so you pay more per microsecond, but you pay for less time. So it's really, yeah, and that for the current pricing model. The day where it changes, you will have to reduce the mass.
Exactly. And then we had a question about, does Quark support Loom, and how do you how is thread pinning? How do you do that if thread pinning is not solved? But that's you don't, and that's why we
Yeah, so there
have this
is two ways. So so no, we don't really necessarily handle pinning. I have ideas of how I can do that. At least warn the users when it happens. However, we have a big reactive ecosystem in Quarkus with plenty of clients, Redis, Postgre, well, almost anything, which are exposed using the Mutiny API. And Mutiny API has blocking operation, which is kind of weird, but you can do an operation and a wait to wait for the operation to complete. That's blocking. That blocking operation has been implemented, that and a wait has been implemented to not pin the carrier thread. So basically, we have clients today which are already usable without pinning in Quarkus. Typically, the Redis client, which I've worked on it for probably a couple of months now, is it's probably the only Redis client in Java that is not pinning the carrier thread. So it's Loom friendly already. But yes, it's not the regular thing. You will have to use this reactive API in blocking, using the blocking thing. So it's not necessarily convenient, but that's the best we can have right now.
You dying over there?
Yeah, you kill Quarkus and no.
All right. We had this as a Loom, and then we have a very important one from Kevin. Who says, "Can someone say hello to my bro?" So that's Julian somewhere. So hi, Julian.
Oh yeah,
Somewhere
that's
down
Kevin.
there.
Yeah, so yeah, Kevin is Julian's brother.
So yeah, we all know each other here. Here's a fun one. What's the advantage of Quarkus versus Spring Native or Spring Boot 3? Well, so the first thing is, the advantage of Quarkus is we've been using Native for a long, long time. And we're very happy that Spring Native have kind of catch on and do some of the similar approaches we do with the Graal native image. And we always say to people, like, we don't want to publish performance numbers and that kind of thing, because it depends on your application. So we do that and we share how to do tests so you can compare the thing. But we will say the reason why we, for example, didn't go and made Spring, we could have helped make Spring native, so to speak, but we believe that the approach Spring has in itself is just too much how we've been doing Java the last 25 years. And the approach we're taking with making Quarkus a build time first approach just solves a lot of problems. It gives, like, well, Clement, you said them, like, it gives us ability to do stuff at dev time. We move everything at build time. So we just physically have less things to do at the runtime. And Spring Native, in the way Spring works, just can't get to that point. So that's I think the main thing, and that's the difference in approach.
There's other things. We have a reactive core. So there is plenty of things that make a clear differentiator.
The reactive approach in Spring is very different from there.
And there is Emmanuel that want to say something, maybe.
Oh,
I think you should say that in this room with actual Quarkus user for production up to 4 years ago, very few in the end use the native, but they keep having Quarkus with a lot of benefit from usage, resource point of view, and all of the good stuff as far as the dev experience.
Yeah.
So native is just one feature.
Yeah. So that's the thing is like if you just compare Quarkus to Spring Boot, or if you run Quarkus in Java mode, it's about half the size compared to traditional web apps.
So and that's very important. Native is not the goal. It's not the graph, I
Yes.
would say, but yeah, it can be useful sometimes. It may not work for all workloads, for all applications. So yeah, don't see it as, oh, I want to use Quarkus, it need to be native. No, that's not true. We have very good benefits, very good startup time, just using JVM.
Yes.
I would go back to my
Then we have another one. So Mark saying, hey friends, any idea what's happening in place persistence? I think it doesn't work on Quarkus 3 yet. So we had a question just say Quarkus 3 is ready for production, which it is. But there are extensions that has not yet upgraded to Quarkus 3. One of the reasons why we actually release Quarkus 3 now is that we could take an approach of waiting for everyone to have moved before we release Quarkus 3. But then we would be waiting forever. So there are a handful of extensions that hasn't upgraded yet. Place persistence is not something that this team is driving. That's not in the community. I don't have any specific update on that extension. But the idea is that we ping everyone and help where we could. And if you are interested in that extension or something else that hasn't moved to Quarkus 3, go on an issue with them, ask. And if anything that is blocking them, we have to help. We've done it for a dozen of extensions, so we know that it's doable. So I hope you get it, at some point. But yeah.
I'm actually getting echo apparently.
I'm getting echo. That's because that one. No, hopefully, yeah. And there we go. So we have Simon. He's actually saying dev UI will be useful in our development system. We never use it in our local dev mode. Well, So he wants to be able to use dev UI in his local, like in his remote testing kind of thing. But he could run in dev mode, but no, don't do it.
No. Dev mode is not production ready. There is one thing that is not production ready is dev mode. We are doing plenty of magic and things like that makes the application.
We're running over time. Let's see here. We had if you're using Vertex, you have a Vertex application. Are there any caveats to supporting this with Quarkus 3? Keep it as Vertex native as possible. There was some threading caveats in Quarkus 2. Is there anything?
Yeah, we fixed a few things there. There are a couple of rough angles that I need to address. There is a blog post which is a little bit old. I think it's 1 year old or 2 years old, which is named Board by Magic Trick on the Quarkus blog, which explain actually how you can use Vertex directly in a Quarkus application and all the steps you can do. So you want no magic, a bit of magic, a bit more magic, and things like that. So you decide the level of magic you want. And as I was previously in the Vertex team, I know that sometimes you just, it depends. It depends on the background, depends on plenty of things. So you have the choice. If you see any more threading issues, just, open issues because, they are not normal. We fixed a few. Well, I still have one on WebSockets. That's clearly something I need to fix.
So basically, upgrade, it'll be better.
Yeah, I hope. Yes, normally, yes.
So we are both over time, and I'm through. We got just
about that. The Quarkus team and the Vertex team are working really hand to hand. The Vertex leader is in the room right now, so yes.
That was Kevin's bro, right?
And that was Kevin's bro, yes.
We have from CPark say, is there better support for OpenTelemetry, or has the same feature set like in Quarkus 2?
We improved a couple of things, at least on the Kafka reactive messaging side. I don't know about the core side, but there is a lot of discussion and improvement happening right now on that.
Yeah. So that should be, it's the same and
more.
Yeah, and more. Yeah.
So OpenTelemetry evolves pretty quickly, so we are always in catch-up mode, more or less. But so.
But again, that's generally is that there are certain stuff in Quarkus 3 that's moved a lot, but also other stuff is just it's the same and continue as it is. Okay, I'm gonna try and stop this now because we're running out of time. So anyway, thanks for everyone, and I want to give a hand to the Quarkus team back there for doing Quarkus 3. So thank you, and we'll shut off here and say bye and thank you online, and
remember why.